Hello and welcome to another video of time series forecasting. And this is a summary of what we did in chapter number 3. The first thing we did was we talked about 4 methods of forecasting. We can either forecast based on the average method, naive method, seasonal naive method, or the drift method. Now in average forecasting method, we believe that we can forecast based on whatever was the average in our historical data. In the naive method, we believe that our last observed value contains all the information that we need to forecast any future value. And if our data is seasonal, we use seasonal naive method, in which case we pick our forecast based on the last observed value in the same season last time. And if our data is showing us any trend, then we may use a drift method. So these were the 4 benchmark methods that I discussed in chapter number 3. And then after we'll have these forecasts, it is very important to perform residual diagnostics to know whether our forecasting method it is using all the available information in the data set. To see if our forecasting method is using all the information which is available, we fit a model and then we find residuals, and then we perform various tests on those residuals to know whether we are using all the available information. So ideally our forecasting method should have mean which is equal to 0. Then our residuals should not be correlated with each other. That is, we can look at the ACF to know whether our residuals are correlated or not. Or we can apply the long box test to know whether our series is white noise or not. And then we can also test for the normality of the residuals by looking at the histogram. And finally, I talked about the forecast accuracy by using various measurements. For example, we can look at the root mean squared error, we can look at the mean absolute error or mean absolute percentage error. And I also talked about cross-validation by splitting your data into 2 parts. You fit your model using the training set, and then you test for the accuracy of the model based on root mean squared error or cross-validation or any other measure that you want to use on the test set. It is very important that you split your data. You train your data on the training set and then test the accuracy of the model on the test set rather than on the training set. So this way you'll have a genuine forecast, and this will give you an idea about how your forecasting method will perform if it is encountered with an unseen observation. So this was what we did in this chapter.